One of the more powerful aspects of at-risk software is the way you can enter randomness or random variables into your workbook. And we're going to take a look at a variety of those ways right now. Remember, we're trying to model EBITDA. So the first way is, you know, the expected value is 212. Say you've estimated the standard deviation to be 53. You can just type it straight in, and that's equals risk normal. The functions are case insensitive. So then the mean is 212, it goes in first, and the standard deviation is 53. And it's pretty much like any other Excel function. As long as you know the syntax, you can just type it in and enter it. And there's our 212. Another way to do this is, just as you use cell references in an Excel function, you can do the same thing in an at-risk function. So here we go again with risk normal. And now you just either click on or go up to the cell that you want to reference for the mean. In this case it's E9. Put in a comma. Go up to the cell that contains a standard deviation. Close your parentheses. Hit enter. And again, you have EBIT defined as a normally distributed random variable with a mean of 212 and a standard deviation of 53. Now, if you can't remember the name of the function, or if you want to look at other distributions that are available to you, you can use the defined distributions option. So let's go up here, and that's this icon, and you'll see defined distributions show up. Click on it. We want the normal distribution here. And now I can enter the numbers directly into the cell. So again, the mean, which is mu, is 212. Now if you notice the standard deviation, we see the distribution show up in this window here, and the standard deviation right now is 1. So you see 212, 211, 210. Well, our standard deviation is supposed to be 53, so let's enter that. Now the distribution shown looks identical, but take a look. Now it's going from 200 down to 150 down to 100. The x-axis has changed to reflect the change in the standard deviation. Click apply, and we've entered it into EBITDA and defined it as a randomly distributed random variable. Now if you want to use cell references, and after all we're probably going to want to use cell references in at least some of our things so we can do some sensitivity studies, then you go up again to the Define Distributions button. And now you need to know the cell addresses. Unfortunately, in at-risk, at least in my version of at-risk, I can't just click on the cell and then click on the cell reference. Now in newer versions of Crystal Ball, this is a possibility. Let's get this so we can see what we're going to do here. Okay, so we want to get these two cell references into the arguments for the standard distribution. So you have to go equals, and then you have to look at the cell reference. In this case, it's E9 for the mean. And here we want E10. Make sure you get the cell references typed in correctly. You don't get the kinds of nice highlights that you get in a normal Excel function. So now you see the mean set around 212, and you see the x-axis going from 200 to 150 down to 100. Click apply. Now if we change these numbers, our cell references are going to change, and we can do a sensitivity study. Like say we expect the mean to remain at 212, but we think the risk is far greater than the standard deviation of 53 captures. So we might want to use a standard deviation of 100 and then run our model and see what the likelihood is of a good or a bad outcome. And finally, when you're entering functions, just as in Excel, you can enter at-risk functions into your cell equations and not have to enter them separately and then reference that cell. For example, suppose we know the quantity sold, this is our demand function, is going to be 200 less 10 times the price plus some random variable, and here we're going to define the error term as a risk uniform variable that has an equally likely draw between -5 and up to 7. And we just type this in like you would any other function. So this equals 200 less 10 times the price, so we can go up here and pull down our cell reference, plus risk uniform, and here we're entering the parameters directly. And now we've defined the quantity sold in terms of the demand function here, that 200 minus 10 times the price, plus a random variation in the quantity sold. For sales, we know sales is equal to price times the quantity sold. So I could, right now, I could just go this times that and get sales. Perhaps I wish to enter my sales as a normally distributed random variable themselves, with the mean equal to the price times quantity sold. Now remember, the quantity sold has a random variable in it for the error term, and I want my sales to pick that up. So instead of just entering it as the product of price times quantity, I enter it as a normally distributed random variable. So here's the equals, bring in the risk normal function. Now I don't need to enter just a cell reference or a hard number. I can enter a function at this point in time. So that function is going to be price times quantity sold. So that's the mean. What at-risk is going to do is going to calculate the quantity sold based on the draw for the risk uniform, the error term. Then this function is going to take the result of that random draw and use that as its mean for sales, and with a standard deviation of 5% plus or minus whatever the sales are. So for the standard deviation, it's going to be 5%, 0.05, times price times quantity sold. So we have expected sales of 1010. These are normally distributed with a standard deviation of plus or minus 5% of 1010. Now let's go to the operating costs. And the operating costs we're going to define as a triangular distribution. We know the worst case, the best case, and the expected case, but we don't have any other idea of what this distribution truly is. So we just type in risk triangle as our risk triang, 0.75, comma, 0.8, comma, and then 0.85. Now risk is a little bit picky about the order in which you enter the parameters. For example, I could not enter 0.8, 0.75, 0.85. It would give me an error message and wouldn't produce it. So we enter that. There's our operating costs, and now we have EBITDA defined as a random variable. So those are just a few of the ways that you can enter randomness into your model. Let's do a little bit more looking around at risk itself. This is the toolbar up here that comes up once you've loaded at risk. Now you can load at risk once you've installed it, either by clicking the at risk icon on your desktop or by opening Excel and then clicking the at risk icon. If you open it from the at risk icon, it will first open Excel and then it will open at risk. If you have Excel open, it will just bring in the functions. So what do we want to look at? Well, the first we're already familiar with, defined distributions. A few other bells and whistles here. Right, we've only been looking at the normal distribution. You can go down here if you know the name of the distribution that you want to use. You can click through here and through the menu. Remember, there's something like 38 or 39 of these possible distributions. Or you can go over here if you have a rough idea of the shape of the distribution of the random variable that you're trying to enter, but don't really know what the name of that distribution is. You can click on the distribution button here and bring up, I'll bring these into the picture, and bring up all of the different distributions that you can, and then say we choose, well, gee, the log normal 2 looks good. You can click on the picture and it goes here to log normal 2. So that's another nifty way to enter information. We'll cancel this. The next icon that you need to be aware of is the add output. And what the add output button does is it defines the variable that's going to be tracked by at risk. As you run iterations, it's going to accumulate the values and generate a histogram of these values. You just click on it. At risk will suggest a name. If you don't like the name, use the backspace button, back it out, and then type in whatever name you want. and hit enter, and now we've defined this cell as an output, and there's nothing in it, of course, but At-Risk will track it. The next one we're going to look at is the simulation settings, and this is a fairly useful icon as well. The first thing is the number of iterations. We tend to enter 1,000. The default isn't necessarily 1,000. Sometimes you have to change it at that, but that's where I begin my iterations. You can go 5,000 up to 10,000, or you can simply enter whatever number you want. Say you wanted 20,000. It will accept that as well. The sampling tab here brings up some useful things. First, the sample type. Even though we're doing Monte Carlo simulation, we're going to use Latin hypercube sampling. As Wayne Winston says, this is the state-of-the-art sampling. Leave that set where it is. The random generator seed you can leave set. It doesn't really matter. The standard recalc button allows you to change what's displayed in your worksheet in the different cells that are random variables. If you want them to display their means, their expected values, you click expected value. If you want to see what the actual draws are, you click on Monte Carlo. And if you want the true expected value, then you click on true expected value. Now, most of the time, the true expected value and the expected value are going to be similar. The differences could be seen if you look at a binomial variable and say you have a binomial variable that has an 80% chance of coming up 1 and a 20% chance of coming up 0. Well, the expected value, if you click on that, it'll show a 1. The true expected value is going to be 0.8 times 1 plus 0.2 times 0, or 0.8. So if I were to have a binomially distributed random variable in there with those parameters, expected value would show a 1, true expected value would show a 0.8, and Monte Carlo would show a 0 or a 1, depending on whatever the draw was for that particular calculation of the worksheet. Once you've set up your model, you go to the Start Simulation button, and that just starts the whole process. Other useful icons up here display the list of inputs and outputs. And that's this button, and we'll use this when we consider correlation. If you click on it, it opens a new window, and it lists all of the inputs and outputs that are in your worksheet. And if you want to drag this over, you can see their whole names. And it gives you the names of the variables, and it also gives you the names of the worksheet in which you can find those variables. So here are all the outputs that I've defined in this worksheet that we're currently working in, and here are all the different inputs. Let's close this. And the report settings, that's over here. I just leave this one set at default. At default, what it does is and we'll see this in the next slide as we run an actual simulation. After it runs a simulation, it'll open the interactive at-risk results window. And this is probably the most useful window that you'll use with your at-risk. The quick output report displays 3 of the most common graphs that are used. I believe it's a histogram of your output variable, cumulative distribution of your output variable, and what's called a tornado graph of your output variable. We'll talk more about the histogram and the tornado graph as we go forward. So if you wanted, you can have it output the quick report. It's nifty because it comes out in a page that you can then just copy directly into a Word document or whatever document you're using. It creates a minor problem in that the graphs in the quick report are not interactive. And then you have the option down here of what to do or where to put your reports. You can put them in a new workbook, or you can just have them as sheets added to your current workbook. It's your choice. So we'll cancel that one out. All right, we're now ready to run a simulation.